For this exercise, what we will do is establish the equations again for the common emitter, but with an emitter resistance between the emitter and ground. So let's go ahead and do the same thing we've done with the CE without the RE. So it's very similar, starting with the currents. So we know we have a current IB going in. We also have a current IC going in, since this is an NPN transistor. And then we have a current IE coming out. And let's establish the current relationships here. Let's write it up using Kirchhoff's law. We know that IB plus IC minus IE will be equal to 0. Okay? Now, notice here that I have 3 unknowns, but I can actually reduce this to a point where if I'm looking for IB or IC or IE, I at least know the relationship between these two. Okay, so let me just write it up in here on the side. We know that, for example, IB plus beta IB minus IE would be equal to 0. And that is because this is IC, okay? Just in case we need it later on if we're doing any current-based analysis. So let's keep that in mind, but let's focus on the voltage. So just the same technique we used before, we're going to look at the left-hand side and we're going to look at the right-hand side. So let's start with the left-hand side. So we know that we have a current IB going through here. We know we have a voltage drop up to this point, VB here. Notice that VB now is no longer VBE, since there is a voltage drop against RE, which is VRE, for example. So that would be IE, RE. So let's go ahead and establish Kirchhoff's law for the left-hand side, okay? So voltage drops, we know we're going to have a voltage drop VRB in this direction. We also know that we would have a voltage drop VRE in this direction, always opposite to the current. So if we write Kirchhoff's law off the left-hand side of the voltages, so we would have VRB plus VBE plus VRE minus VCC will be equal to 0. Okay? Now, knowing that, we can substitute now VRB for, let's say, IB, RB, okay, plus VBE, so we'll leave VBE alone. And VRE, we can actually write it in terms of its current, IE times RE minus VCC equals 0. Fantastic. Let's leave this equation here. This is an important one right here. And let's work on the right-hand side of the circuit and also establish Kirchhoff rules. And we now know that we also have a voltage VC here, right, against VR, or you can call it VRC if you want. Let's call it VRC, okay? So let's go ahead and do that. So we have VRC plus VCE plus VRE minus VCC equals 0. There you go. All right, so now let's go ahead and express these in terms of currents. So VRC would be IC RC plus VCE plus IE RE minus VCC equals 0. Fantastic. Now, knowing this, depending on what we're solving for, we can actually use, for example, this equation to relate the front to the end, right? So how do we do this? Well, first of all, we know the relationship, just like we did before, between IC and IB. So we know that IC equals beta IB, right? So we know this. So if we're interested in going from one end to the other, obviously beta is going to come into play. Okay? So now, let's say we're interested in a final IE current equation. Okay? Now, we could look at it from here and say, on this side, IE is going to be equal to IB plus beta IB. And we could say that is IB times 1 plus beta. Okay? That would be IE. Now, what can we do? Well, what we can do is we could use the IB here, and we could extract it from here and put it right here. We could do that. Okay? We could also look at this relationship between these two, and we could do it that way. So there are several ways in which you can do this. So let's say we do it this way. So we have IERE equals to VCC minus IB RB plus minus, I'm sorry, VB. Now, can we replace IB by something else, by a value? Yeah, we could, knowing that IB is here. So what is IB? Well, that's going to be equal to IE divided by 1 plus beta, right? So something like this. Can we put it in here? And the answer is yes. So we could have an IE RE equals VCC minus IE times RB divided by 1 plus beta, right? Minus VBE. Excellent. Can we move the term that has the IE to this side? Sure. We could do IE RE plus IE RB over 1 plus beta, this is RB, equals VCC minus VBE. Can we factor the IE? Absolutely. IE times RE plus RB over 1 plus beta equals VCC minus VBE. Can we extract IE now? Absolutely. IE will be equal to VCC minus VBE divided by RE plus RB divided by 1 plus beta. Excellent. So can we figure out IC with this? Sure. There is a relationship between, right here, we can come back to this and say, okay, well, what is IC? Well, there are several things we could do. We could say that IE, or if you want, or IC is equal to IE minus IB. Okay? We already know the relationship here. So if you want it in terms of beta, you could do that. So you could do something like this. IC equals IE minus IC over beta. Can we move it to the side here? Sure. IC plus IC over beta equals IE. And can I factor the IC? Sure. And that would be IE divided by 1 plus 1 over beta. Now, what can I do with this IE here? Well, you can put right here what you have and replace IE with that value. You can do it that way. Okay, so that would give you the value for IC based on these elements here. Okay, any other ways to find IC? Absolutely, you could do it this way. And this here will include the RC as part of the equation, so it's a factor of RC if you wanted to. Okay, so there are several ways you could do this. So let's do this one. So for this one, IC, RC plus VCE. And we know that IE is IC plus IB times RE minus VCC equals 0. So again, I extracted it from there to this. Okay, so what can I do with this? A lot of things. You could factor out the ICs from this side. You could replace IB by, so you could do something like this, ICRC plus VCE plus, this is VCE, IC plus IC over beta times RE minus VCC equals 0. Right? So we can factor all the ICs here out of this. And now we're going to find the equations for IC based on RC value. Okay? So if we do the math here, so let's go ahead and factor out IC. And that would be VCC minus VCE. And the whole thing divided by RC plus RE times 1 plus 1 over beta. And there you have it. So you have different ways to find a IC, depending if you're looking at in factor of RC, or if you do it with this IE here, it will be based on the other resistance values other than RC. Okay, so you have choices here on how you could solve for that.